Good morning, everyone. Today's topic is transaction concept. So, we'll see what is a transaction. See, a transaction is an action or series of action that are performed by a single user or an programmer or an application programmer. So, here a transaction is said to be an action or series of action, and it is also it is also called as a logical unit of work that we are going to do on a database. So here, whenever we are going to tell that we are going to work on a database, that means we are going to perform read or write operations on the database. That is, read write operations are done on the database. So finally, a transaction is nothing but an action or series of action that is being performed by a user or any programmer. So it is also defined as a logical unit of work that we are going to perform on a database. So this might be an entire program. The transaction can be an entire program or a piece of program or a single command also. And it may engage in any number of operations on the database. The operation can be assigning, updating, performing logical operations, so etc. In the database, in the database context, the execution of an application programs can be thought of as one or more transactions. See, a transaction means there suppose I1 to I100. So I1, I2, I100 are all the collections of instructions. So each instruction here it is said to be as a transaction. For example, and a transaction dealing with a bank account. See, suppose there are two people like Carlos and Ray. So here an example what we are showing is we are going to reduce we are going to transfer 5,000 amount from Carlos account to Ray's account. That means 5,000 amount is being transferred from Carlos account to Ray's account. So these are the set of instructions it is undergoing. That is, first we need to open the Carlos account. Then his old balance is nothing but what is the present amount in his account. So new balance is equals to, we are going to reduce that 5,000 amount because we are going to transfer this 5,000 to Ray's account. Reduce the from the old balance 5,000 you are going to reduce from the old balance, so that will become now new balance. So update that as update that in Carlos balance. Then finally close the account. These set of instructions are nothing but transactions. That is, opening the account, we are going to read the old balance, decrease the specific amount of balance, that is here we are going to do 5,000, then save this as new balance, then finally close his account. So this is all about Carlos set of instruction. Then this 5,000 whatever we have reduced from Carlos, we are going to update in the Ray's account. So again Ray's means again we have to open his Ray's account. His old balance will be equal to whatever the present balance, and new balance is equals to old balance plus 5,000. Then Ray's balance is equals to this new balance. Finally close the account of Ray's. So here again we are going to perform set of instruction in Ray's account. That is, opening Ray's account, reading his present balance, that is old balance, increase his balance with 5,000 amount, then finally save this as new balance and close Ray's account. These are the second set of instruction going to be performed on Ray's account. So this is what transaction is happening. These set of instructions are called as transaction. We are going to perform transaction of 5,000 amount from Carlos account to Ray's account. This is nothing but a transaction. A transaction is a logical unit of work on the database, or an action or series of action that is going to be performed by a single user or an application programmer. Next we will see the transaction states. So here the figure shows the different states each transaction is going to go through. Like, see, suppose there are instructions I1 to I100. So whatever it is a first instruction, it is going to enter into the active state. A transaction is a sequence of operation, we already know. So this, whenever a transaction is in execution, then it is said to be in the active state. It is said to be in the active state. So it doesn't matter which step is in execution, until and unless the transaction is executing, it will remain in the active state. During this state, it is going to perform read and write operation on the database. So see here, 1 minute. So a transaction is in execution, then it is said to be in active state. Doesn't matter which instruction, but if it is in active state, that means it is executing. So here it is going to perform read write operations when it is in the active states. So we'll call it as a failed state. When we'll call the state as a failed state, when there is any system failure like hardware failure or software failure, then it is going to enter into the failed state. So the active state will enter from active state, it is going to go into the failed state, or from the partial committed it is going to go to the failed state. See, next we'll know what is partial committed state. A state is said to be in partial committed state when half set of instructions are done. See, whenever you're going to do modification to the database, that copy of a database copy from the disk is bought into the main memory. The copy of database from disk is bought in the main memory, and their updations are done. So if all the updations are done till the end, then these changes are reflected on the disk database. If any failure occurs in intermediate, then it will go back to the first database. Like no changes are done to the database will be as it is. If all the instructions will go through successfully from start till end, then only these changes will be updated in our disk database, or else it will go back to our old database only. So that is partial committed state. See, in partial committed statement, the transaction enters into partial committed from active state when there are read and write operations present in our transaction. So once the whole transaction is successfully executed, the transaction goes in partial committed. But when we have all read and write operation performed on the main memory instead of the actual database, we are not going to do changes in our actual database. Only that copy we are going to get in the main memory and perform operation there. The reason why we have this state is because a transaction can fail during execution. So if we are making the changes in the actual database instead of main memory, database may be left in an inconsistent state in case of any failure, like for example. This state helps us to roll back the changes made to the database in case of failure during execution. Next we'll see what is committed state. If next is committed state. When all the transactions are done, suppose from Carlos account to Ray's account, if all the transactions are done successfully, then it will be in the committed state. If only if half set of instructions are done, that is in from Carlos account 5,000 you have reduced, but after that the system has failed, then that is your partial committed. So that updation will not be done in our disk database. So again, the whatever Carlos old balance was there, it will keep as it is and no changes will be done if it has halfway completed also. So that is a partial committed. If all the instructions, like first from Carlos all 5,000 is reduced, after that next instructions also like 5,000 is been updated in Ray's account also, then it will go in the committed state. That is permanently it is going to store in our database disk. It is going to permanently store it on our disk database when it will enter into the committed state. Next we will see what is aborted state. If any transaction fails during the execution, then the transaction goes into the failed state. If any transactions is going to fail in middle, then it will go into the aborted state. So whatever changes you are going to do in the main memory, so it will roll back and get back to our previous database only. So no changes will be done to our database. That is aborted. So stop your execution and resume it. Whatever previously you had database, you will get the same database. No changes will be done. Finally is your terminated state. So this state will reach when all the transactions have been completed and your instructions are leaving the system, and your transactions are leaving the system, then it will be in the terminated state. So these are the different states, that is the transaction states, that is active state, partial committed state, terminated, failed, and aborted state. Next we'll see the facts about database transaction. See, we already know a transaction is nothing but a logical unit of work or an action or series of action that is being performed by a user or a programmer, that is application programmer. So if a database operation doesn't update the database but only retrieve data, then it is called as read-only transaction. That means if you're going to take your database from the disk to your main memory, and you're only going to read and you're only going to perform the read operations there, you're not going to perform any updation there, only you're opening your account for reading. That is, suppose if you want to check your balance in your account, so you'll take from the disk database, you're going to put in the main memory, from there you're just going to know your balance, then finally you'll perform all close and all and exit. That is called as read only transaction. So for that also you need to give some instruction to read from the disk to your main memory, that is read only transaction. A successful transaction can change the database from consistent state to another. See, when a transaction is called as a successful, a transaction is said to be successful only when it will enter from one consistent state to another consistent state. That means we have seen the different transaction states. So it has to enter from when it is moving from one state to another state, it has to be in consistent state. All the states should be inconsistent, then it is said to be a successful transaction. If any one of the transaction is inconsistent and still you're performing any transaction, then it will not give you any efficient result. So dbms transactions must be atomic, consistent, isolated, and durable, then that transaction is said to be successful transaction or efficient transaction. So it has to follow these four properties, that is atomic, consistent, isolated, and durable. See, why do we need a concurrency in transaction? See, nowadays in real-time examples, we see everywhere concurrency. So that means at a single time, so many people are accessing the same operation. Like we'll see, for example, in banking system, or like suppose if you are booking any movie ticket. So at a time, at a time, so many people will be booking the tickets in that particular place. Or suppose if you're booking any Tatkal ticket for any particular train, so it will be opened at morning 10 o'clock somewhat for 2 hours like that. So at that time only so many users will be having access to that particular operation. So that is called as concurrency in transaction. So at a real time we are having the concurrency in most of the application, like for example banking system, railways, air reservation system, stock marketing, supermarket inventory, and checkout. So like you can write your own examples also. We are having so many places concurrency. So what are the issues that we are going to face when we are going to do concurrency? Like you'll be having hardware failure, or like hardware or software failures that you're going to face, and system crashes. Suppose for example if there is any hardware or system crashes, like for example Amazon or Flipkart, if there is any fault in the system, then it will perform upgradation. Sometimes you will get system in progress or upgradation is going on, so wait for some time, like that. So that is nothing but because of some failure only upgradation is going on, and they'll resume back the service. So this type of issues we are going to face in so many sites. Next is concurrent execution of the same transaction. Suppose more than one people are aiming to book for the same place in a movie ticket, like same place, same location. If they are booking the same ticket, then they'll face some issue there. Next is like a deadlocks or slow performance. Like if there is lot of if your system is having so much of information or so much data put in that, then if you're going to do any transactions and all, the system will slow down. That means there will be some degradation problem. So these are the some of the issues that we are going to face when we are going to do concurrent access to any particular application. So this is all about the transactions.